Good morning, students. Welcome back to your mathematics class once again. Today, we are going to be looking at a very interesting topic in geometry called Pythagoras theorem. In today's lesson, the objectives that we want to accomplish are to understand the concept of Pythagoras theorem, define and identify Pythagorean triples, and use Pythagoras theorem to find any missing side of a triangle. So students, right off the bat, we can see that we have a right angle triangle. And we know that this is a right angle triangle because it has a small square in a corner of the triangle that is opposite to the longest side. Alright? And this triangle we have here is enclosed by three squares. So let's take a look at part A. So the first thing we are trying to find out is the area of a square. Now we should know already by now how to find the area of a square, and we do that by multiplying one side by itself. Alright, so then if we multiply 5 times 5 we will get 25. If we multiply 4 times 4 we will get 16. If we multiply 3 times 3 we will get 9. Moving on to B, what side of the triangle is the hypotenuse? We know that in any right angle triangle, the hypotenuse is always the longest side. So in this case, the hypotenuse is side C. Right. Moving on to C. Write a statement that represents the relationship between the areas of the three squares. So there are three areas. What would these three areas be? We have 25, we have 16, and we have 9. So what would the addition statement be for this relationship? So we can say a squared plus b squared will be equal to c squared. And now we can substitute a, b, and c and say we have 9, we have 3 squared, plus 4 squared equals 5 squared, and that will give us 9 plus 16 equals 25. Right. So this is what Pythagoras theorem really is. The relationship between the sides of a right angle triangle, that's important, and it basically allows us to find a missing side with knowing the other two sides. Okay, so let's move on to part B. So the question asks, a triangle has sides of 5 centimeters, 7 centimeters, and 9 centimeters. What are the areas of the three sides that can be drawn on the sides of the triangle? So, in this case, we have 9, 7, and 5. For us to find these areas, we know already, to find the areas of the square, we must multiply one side by itself. So in this case, we have 9 times 9, that will give us 81. We have 7 times 7, that will give us 49. And we have 5 times 5, and that will give us 25. Okay? B says or asks, is this triangle a right angle triangle? Explain your answer. Now remember, in Pythagoras theorem, the rule only applies to right angle triangles. Okay? So, like we saw a while ago, if we were to write 25 plus 49, it must equal to 81. So let's see if when we add 25 and 49, we will get 81. As we can see, it doesn't equal to 81. So B asks, is this triangle a right angle triangle? No, it is not. Because in this case, if we were to square 5 centimeters, square 7 centimeters and add them, it will not be equal to 9 centimeters squared. So in this case, Pythagoras theorem does not apply, and this is not a right angle triangle. So all triangles that are right angle triangles, their sides form something called Pythagorean triples. So we can see that with 3, 4, and 5 as earlier, right? These sides form a Pythagorean triple because it proves that if we were to square 3 or multiply 3 by 3, we will get 9. Multiply 4 by 4, we get 16, and it will all be equal to 5 times 5 will be equals to 25, right? So this is what we call Pythagorean triples. 3, 4, and 5 are considered to be Pythagorean triples. So let's look at what we have to the side in this table and prove whether we have Pythagorean triples or not. So let's look at 5, 12, and 14. If I were to square 5 and 5, that will give me 25, right? If I were to multiply 12 times 12, that will give me 144. And if I were to multiply 14 times 13, it will give me 169. So if we add 144 and 25, will it give us 169? Yes, it will. So we can take that right there. Let's try another one. Let's try 4, 5, and 6. If we multiply 4 by 4, we will get 16. If we multiply 5 times 5, we will get 25. If we now multiply 6 by 6, we will get 36. But does 16 and 25 equal to 36? No, it doesn't. So therefore, 4, 5, and 6 is not a Pythagorean theorem. So what I want you to do is take some time off and do these other three and take or prove to yourself whether these are Pythagorean theorems or not. Okay, students, let's look at this example here. So we are trying to find the length of side C. So using Pythagoras theorem, you may want to take a moment to do this on your own and see if you can get the correct answer. Okay, students, let's take a look at the example we have here. So we are trying to find the length of side C. So in this case, you can see that side C is the hypotenuse or the longest side, right? So using Pythagoras theorem, as we mentioned before, we have a squared plus b squared equals c squared. If we substitute, we'll have a for 3, b for 11. If we multiply 3 times 3, we'll get 9. If we multiply 11 times 11, we'll get 121. Now, if we add 9 and 121, that will give us 130, right? So we have c squared equals 130, and to find that answer, we will remove the square and find the square root of 130, which will give us 11.4. Okay? Okay, let's look at a second example. In this case, we are trying to find side A, right? So again, you may want to take some time off to do this on. I'll give you a few minutes. Right, I trust that you had enough time. So using Pythagoras theorem, like I said before, a squared plus b squared equals c squared, right? For us to find a, right, we need to make a squared the subject of the formula. So we then have a squared equals 15 squared minus 5 squared, which will give us a squared is equal to 225 minus 25, which will give us 200. So a squared will now be equal to 200, but we don't want a squared, we want a. So then we remove the square and we find the square root of 200, which will give us 14.14. Students, so now at this time we're going to have a video recap of what we just did, so please pay attention. Right, I hope that video was a good little reminder, a nice visual as to what we learned earlier. Now, what I'd like you to do for homework is to take down this triangle as is, and I would like you to use Pythagoras theorem, right, to find the missing side. In this case, the missing side is B. So you've done two examples of how to find a side using Pythagoras theorem, and when we come next class, we will see how well or how much you've learned.